Thank you for that intro, Chanel. Yeah, so we'll start with the overview of what is shared AR. And so this actually is more specific to what is web shared AR, because we do have shared AR on Unity, but we're going to focus on 8th wall shared AR. So shared AR for 8th wall is a service and API that allows you to connect up to 32 users together to play in the same room. You can send network messages and use network A-frame out of the box. There's a couple of caveats that we can talk about, but in general, it should be pretty seamless to send messages from peer-to-peer and perform pretty common networked operations. Also, we provide a set of lobby pages that allow you to wait for players to ready up, meet up in a lobby page where they can all wait until everyone's ready, and then once everyone's ready, the actual game starts. And you'll see that throughout this workshop. Now, before we continue, we'd want to create a small, quick poll just to get a sense of where everyone is. And that poll, I think Chanel may be preparing that. There's a question that says, have you ever created a multiplayer experience before? So I'm going to wait for that, I think, unless you want me to set that up, Chanel.
No, I can set it up. I don't see it. It's not working for me right now. So let's just do that in the
just
chat.
Do a quick chat. Yeah, quick chat check. So has anyone created a multiplayer, not necessarily AR, but any kind of multiplayer experience before? Someone has a board game. Oh, people have used Niantic Lightship. That's good. So some people are familiar with our Lightship platform. Okay, someone used sockets. We actually used WebSocket for this. That's good. Yeah, actually, there's quite a few that have already used it and dipped their toes in multiplayer. So that's great. That's actually I was leaning towards like that's maybe like 90% no, but this is actually more like 50-50 or more than 50 have tried it. So that's awesome. Yeah, so if you've already have, then you may have encountered some of the challenges that we'll see. If you don't, then hopefully this should be an easy intro for network, and we'll try to keep it as simple as possible. So yeah, let's start with the actual workshop. There will be links, by the way, I didn't preface with that, but there'll be code links at some steps of the workshop. If you cannot follow along because the typing of the code itself is pretty fast, what have you, just open the link of the code as soon as possible. I think Chanel, did you send the slides? Great. So Chanel must have sent you all the slide link. So go ahead and click the links at the right times when you go through it, and that way you'll have the reference. You can either copy paste it. That's absolutely fine if you're running out of time, or try to type along. So as we go, we'll try to learn. We'll do 3 main objectives. 1, learn about the room store or data store, room data, by adding the Ingress faction selection to your project. So we're going to add some Ingress flavoring to this. We're going to change the scoring so that instead of it being a last crab standing, it's going to be a team game. So it's going to be Ingress resistance versus enlighten, and it's going to be the team that has crabs remaining wins before the other one. The team that has no crabs in the pot left, or all the crabs in the pot, actually, that team loses. And we'll learn about and we'll do that using peer messages, which I'll go over what that is. And finally, we'll learn about clock sync or universal clock to synchronize and resolve race conditions. So let's get into the coding part of this. First off, we're going to create the project. So you're going to want to navigate to 8thwall.com, click on the project library there, and we're going to search for a project named Hot Pot Hop, but you can just type Hot Pot and it should pop. Once you find that, go ahead and click on the clone project button. That should allow you to grab that project and create your project based off of it. So after you've hit clone project, you're going to select your personal workspace. There's going to be a select workspace tab or combo box. You're going to select your own personal workspace. You can create a name for your project, whatever you want. Workshop, whatever. It's under your workspace, so it doesn't matter. You don't have to make it a unique name. It's only unique to you. And then under license type, make sure you select demo, and then you can hit create. That should be it for creating the original project. So maybe give it a few seconds, a minute, and then we'll get into, once you're done with that, react with a check. And if you have any issues with the steps, then react with an X, and we'll try to assist you as much as possible.
Some checks. Let's get more checks, you guys, using the reactions at the bottom of your Zoom toolbar. If you have the sample project cloned, I have dropped it in the chat as well. If you just want to click that link and clone it to your workspace and anything useful. Okay, let me have a check from Matt. Thank you, Matt. We have a check from, let's see. That's all. Okay, I think we can go forward now.
Okay, great. So now that you have your project, before we begin, I wanted to talk quickly about lobby pages. Lobby pages are a WebAR or 8th wall specific feature that allow you to connect automatically to a newly created room. So normally there is the room connection, we call the room connection API. This all, by the way, all this information that I'm saying right now and forward is in the README. The project you just cloned has a readme.md that has a big reference on all of our multiplayer API, as well as this lobby that I'm explaining. So our multiplayer API is based around rooms. We use rooms to connect players. And normally you'd have to create a room yourself, and that generates a unique ID, and then all players join it, and that's how you normally start a game. Lobby simplifies this for you so that whenever you include this lobby component in your project, a room is automatically created for you. And so as players join, as you saw in this demo that you just played, as players join via the invite link, they automatically join this room. And as players ready up, as you can see in the, well, I'm not sure if this GIF here shows it, but as players ready up, you'll eventually get everyone is ready, the countdown starts to start the game. And so as that happens, different events occur and that the developer can subscribe to. Countdown start, as the countdown starts for 0, 3, 2, 1, 0, game starts, and countdown done as that same countdown finishes. These two events contain some information like the players that have joined, their names, and so on. And that's probably what you'll want to hook up to, and we'll do that in this workshop, to start your actual application. If you need access to other things that have to do with networking throughout the game, not necessarily, you don't want to sign up to Countdown Start, you can also use this Get Lobby Room Connection, which gets you access to the multiplayer API, to the Room Connection API at any point in time in your application. And we'll also do that in the workshop. There is a room joined event that you can subscribe to as well, which basically gives you this connection. So you can get this connection to the room in different ways. Importing and using the lobby pages is very simple. This is already done in this project, but if you need to do it in a project, you're going to import the shared AR module via that plus icon here in the modules. And you're going to add the lobby pages component to the A scene. A scene is a A-frame construct. So I am assuming here that you know a little bit of A-frame, but there will be an A scene object in body HTML, and this A scene has a set of components. Lobby pages is a component that will be in your project as a sample, and it has a set of options. I'm going to say now that for testing, you're going to want to set up this lobby page.min players to 1. So that you can, what this says is you can actually start the game when only one person readies up. This is very useful for testing because then you can just play the game as you ready up. You don't have to have 2 tabs open and so on. And speaking of tabs, another option that's good is new tab, new user, which lets you open up a new or create a new user every time you open a new tab. This is very useful for testing multiplayer because you can just open 10 tabs and you now have 10 users. So you're going to want that set to true for this project as well, for this workshop. So that's kind of, we already know, I'm assuming that you know how to save and build, but if you want to test the lobby right now, you can go ahead and save and build this project and preview it. And then you should be able to enter the game, the hotpot game, locally on your browser. So there's no checkpoint here. Chanel, I'm not sure. I think at this point we're okay with kind of just moving along, just because we're a bit tight on time. Feel free to, if you have time, save build and preview it, but we're gonna assume that everyone has their project working and everyone is ready to build. So next we're gonna actually start with the select your faction UI, which is the classic Ingress Enlighten versus Resistance faction. And so we're going to do that by first adding the HTML necessary for this. Again, this is pretty fast typing on the right. You can see that we add a faction card, and this faction card has a choose faction title. It will have a couple buttons. I don't expect you to type this fast. This is kind of crazy, but you can click the code here, and then you'll see the faction HTML that you need to paste into your body.html that has all the other UI HTML in here. And so you can see here the choose faction card with a button for Enlighten and a button for Resistance. This is just the HTML for it. And then very important, you'll also want to add the choose faction component into your ascene in the body.html. This is a component that we haven't written yet. We're going to write it, so don't expect to save build and have this work. But this is the first step for creating this UI is going to be adding this choose faction component and adding this here into the ascene and adding the HTML here on the body.html where other UI elements are. So I understand this is a bit fast, so hopefully everyone can catch up, but I'm going to move forward to the JavaScript and CSS part of this. So next we are going to create two component files. One is going to be the choose faction.css, which contains all of the CSS for that HTML we just created. And the other is going to be the choose faction.js, which is going to contain the logic for showing this faction HTML that we just created. For the CSS, I definitely don't expect you to type this right now, especially I literally just this GIF already went through it. But I expect you to just copy and paste because it's just a bunch of CSS setting up the alignments and also so forth for the HTML. So just copy this code from the gist and then paste it in choose faction.css. And for the JavaScript, you can probably type this up or just copy it, but very quick and easy to understand. We're just going to grab this faction card. We're going to show it and pay attention to this here. We're going to show it once the lobby 8 countdown done event is received. So this is what I was talking about earlier when I was saying that the lobby has a set of events that your application will hook up to. This is how we hook up something to happen once the lobby is done, once everyone has readied up, once everyone countdown has reached 0, then we subscribe to countdown done. And then once that happens, we will remove the hidden attribute from our choose faction. Basically, this just shows the choose faction card. And so that is all you need for just showing a UI at the beginning of the game. So I'm going to go ahead and, oh, sorry, I did miss one step. So we created a component, but we forgot to register it to A-frame. So we need to do that. That is the one last step. And that's very simple, very small. I think it's 2 lines. You import the component from components choosefaction.js, and then you call A-frame.register component. And the name is the same name that we put on ascene, choose-faction. That tells A-frame that whenever you add choose-faction to your ascene entity, you're going to be using this JavaScript choose faction component that we just created. And that should be it for adding this new component that shows the choose faction UI. Oh, and I keep forgetting one thing. So I thought I thought I had broken this down in separate steps. So apologies for that. We do need the images. So this UI has 2 images. One is the Enlighten and the other one is the Resistance icon. So there are 2 images in this folder here. You're going to want to open up this link and copy or drag and drop the PNG files into a newly created image folder into the assets folder. So go ahead and press the plus button here, create a new folder named image img, and then drag and drop the ing_enlighten and ing_resistance.png files. And that is actually it. So I will give some time here for people to catch up. I do know where it is quite a lot of code in little time, but should be able to give a few seconds for people to catch up. Now, while people catch up, I will comment on this because this still looks pretty broken, right? So like you can see that the choose faction shows up, but it just kind of shows up on top. There's really not, it should, the game starts and you still see the UI. So obviously this is something that we'll need to fix in the next step.
People don't have access to the images, so I'm going
Okay.
to just download them and then re-upload
Okay.
them. Or
Sounds good.
I might be able to put them in the Zoom actually. Let me just do that for
Yeah,
now.
sounds good. So yeah, the only problem, I guess, that the project won't build until they have the images. So what I can continue forward and kind of like defer the build, or do you want to just wait for that?
We can wait. I'm going to just do it.
Okay.
Okay, I'm about to drop it right now. Faction assets in the chat. There you go. Please confirm that works. We all have kind of different permission settings at Niantic, so had to redo that so everyone can access. Yay, get a thumbs up. Awesome. If you want to give us some check marks or thumbs up or in the chat, just say that you have your assets inside, and then Danny can move forward. Okay, I think we can move forward. The files may need to be renamed, so just be aware of that, y'all. And you do have the slide deck, so you can follow along.
Okay. Yeah. So if you do need to rename the files, just go back to, and I'm gonna try to do this real quick, but you should be able to, I believe it's in the CSS. It's probably on the choose faction.css. So go to choose faction.css and match the name there. If you do have any name, or you can just rename it to match what is expected. So we're gonna go ahead. Hopefully we can catch up whomever hasn't caught up yet. Did I? Okay, I didn't. Okay, so now next step is going to be actually use this faction selection and store it. This is going to be our first interesting networking step. We're going to grab whatever the player selects and also store that into what we call the room data. I don't expect you to follow this along as I explain this, but I'm going to explain real quick what room data is. Room data is a key value store that you can access at any point during your room lifecycle. This means that this data is not persistent. So this is not something to be used for like a leaderboard or something like that. This is so that you can store, example here, the faction that a user selects, or data that you want other players to be able to see at any point in time of the application. This is useful for game state that persists throughout the room, not after. Things like the faction, things like the score, like how many players are alive, stuff like that. This is a bit different than peer messages. And so I want to make that clear, and I'm sure there's going to be questions about that. I'm not going to go into details right now. But just know that this is a perfect example for the use for faction choosing. So if you look at the code on the right or the code in the GIST link, what we're doing is rather than just waiting for countdown done and removing this UI, we are going to still remove the UI, but we're not going to, whoops, I messed up here. We're going to add a listener to the button. And we're going to, whenever the button is clicked, we're going to get the room connection. Remember we talked about calling that get lobby room connection method. We're going to get this room connection. And we're going to call set room data. This is our API for modifying this room data. And this is automatically going to be forwarded to all other peers. We'll go over how that happens on a later slide. This is going to be a message to all other peers so everyone knows what faction I have chosen. And then we're going to emit this faction chosen event. What I'm trying to do here is, because we need to change the flow of the application, our hotpot application, the one we just cloned, will be probably listening for countdown done. But instead, what we need to do is hijack this and say, only this component is going to listen for countdown done. And then this component is going to emit this other event. And our application should listen to this new event. So now the next thing we're going to have to do is we're going to have to, and by the way, Enlighten, this gave me a lot of bugs. Enlighten is written like this. I put this like written thing here intentionally so that you all pay attention to this. If you have bugs in the code, make sure you type Enlighten correctly. This is also why constants are good, but I made sure to highlight it here. Anyways, back to the events. Important that we now, rather than listening to this countdown done, our application is going to want to listen to this faction chosen event. And notice that what we're doing here is we're forwarding all the data that was given to the original countdown done event through this event object is being forwarded here to this faction chosen event. We're kind of like acting as middleware or interceptor or what have you. We're forwarding this data. And so now here on the right, you can see how we change from room joined and lobby countdown done to faction chosen. So that's the key here. This is how we change the game flow from starting up the moment that the lobby is done to starting up whenever I have chosen a faction. And so now we should have, and I know that's going to take a bit because you have to go through all occurrences of lobby A countdown done or lobby A room joined, and you have to replace those. But after we've done that, we should see that the game now waits for ready up. This is not looping, so that's unfortunate. But you would have seen, if you paid attention at the beginning, I kind of wish I could reload it. You would have seen that the game didn't start until you click on the buttons. Now, as people catch up, I'm also going to mention that this is also not in sync. So there's definitely some work to be done here. We're not done quite yet. We just need one small change. But we do wait on the faction selection. We just don't. You notice that this peer on the left, this player, hit the faction earlier. So the countdown is actually going on before this player on the right hit the other faction, right? We don't want that. We need everyone to start at the same exact time. And we're going to handle that on the next step. But first, we're going to wait for everyone to ready up here.
Let's see some checks using the reactions feature in the toolbar. Would love to make sure that we can move forward. Again, I've shared the slide deck for you guys where you can access all of the Git links. And then this is being recorded, so you can review it at a later time as well. So let's see how many checks we have. Let's see. Myra, thank you so much for the check. Anyone else have check marks? Okay, thank you, Francis, for the check. That's Joe, thank you. So many more check marks, y'all. Victor had one up. Labardo, thank you, thank you. Parash Hasti, awesome. I think we can move forward. Looks good.
Okay, thanks. And thank you all for powering through this. I understand it is pretty fast for what it is, but yeah, we can always revisit it later, and this is recorded, so we'll try to have a step-by-step after this so that you can go through it. Okay, so for the next step, we're going to solve this issue where we're not waiting for every other peer to be ready. We need to, just like the lobby waits for everyone to be ready, we need to make it so that we wait for everyone to choose their faction. So here's where I mentioned earlier that when we set room data, that data is being forwarded to all other peers, all other players in the room. And the way you listen for that is by calling this register on room data method of room connection. So that's exactly what we're doing here. In this code here, what we've changed is that we set the room data, and then rather than immediately emitting a faction chosen event, we wait to see if all peers have chosen a faction. Now, this is kind of a mistake on me, I think, on the recording, but basically this method was seen previously here, but I guess there was a scroll up, so you don't see it. This method, what it does, and it's on the gist, it just goes through all of the room data and checks whether that room data is set for the peers. Chanel, I'm not sure if we can reload this or if I go out of the PowerPoint and back in. Okay.
I need one exit full screen.
Okay, yeah, that did it. Great. So thank you. Yeah, so this is the all peers method. So handle all peers, goes through the room connection, peers in room, and if any peer doesn't have the room data for that peer ID prefix faction. So notice that that's how we set the peer ID faction as the key. And so then we check, is this peer ID faction set? And sorry, this is going too fast. That's something that we'll just change the slides in the future so you can see that method at the bottom. But basically here, we're waiting for all peers that have chosen well, we check first, have all peers chosen the faction? That's most likely not going to be true, especially at the very beginning. So if not, then we're calling this register on room data. And what this does is say, anytime that a key value pair is written in this room data, I'm going to call back this method. And this is a very simple way to do it. You could actually inspect the key that you just see as changed, but instead we're just saying, if any room data at all is changed, then check again whether all peers have chosen the faction. And if so, emit the faction chosen event. Otherwise, if we already had all peers chosen, if all peers in this room had already chosen this, then we just continue with faction chosen. So this is I would say, the very first kind of like race condition / networking synchronization that we see in this workshop, and it's done through room data. So that is actually in the next checkpoint. This is all the code we need for, you see how we can choose a faction, the screen kind of goes black, and then the countdown is actually on sync this time because both peers are waiting for the other peer to select their faction. So we're gonna, maybe I'll go back here to the slide while we wait. That may be more useful. And then we'll wait for some checks.
Awesome. And someone just asked, can we get this final project of the workshop to review in detail? Yes, Danny has published it, and it's clonable for all of you guys to clone it and look at the code yourself in the code editor. But yeah, let's get some checks to see if we can move forward. Anyone have some green checks? Yay, Joe, thank you so much. Okay, Labardo, gracias. See, any other checks? Rosh Hosty, thank you. Let's see, any more green checks? I know some of you guys may just be watching and want to follow along later too. It's totally fine. Okay, I think we can move forward.
Okay, I know I was assisting someone in chat, Chanel, if you don't mind following out on that, I'll go on with this meanwhile. Or, we can maybe ask at the end of the session. Okay, so now that we have actual waiting on the faction, we should show the faction. We should make sure that we show the color of each team by changing the way that the Cre8te colors are chosen. And this is done through the get player color method. So what we're going to do is we're going to change there's already a get player color method in the multiplayer.js. So go ahead and search for that. And we're going to remove all the code there. And we're going to simplify it by just saying, first, very important, we make this method asynchronous because it's going to be using the await keyword here to get the lobby room connection. And we're going to get the room connection. We're going to make this asynchronous. And we're going to just say, get the faction by getting the room data.get peer ID faction. And then if the faction is enlightened, remember the spelling here, then return green, otherwise return blue. So that this method is much simpler now. Very important as well, the get player caller now is a promise. It's an asynchronous method. So I'm going to reload the page so you see one more time. But this is now awaiting. So my caller equals await this get player caller. And that was also very quick, but you also have to bubble up the asynchronous method. Spawn Cre8te also became asynchronous. This is also all explained in the gist, but just be careful when you change something to asynchronous, when you make something a promise, everything has to bubble up to also be a promise. Yeah, and if anyone's wondering why get lobby room connection is asynchronous, that's because this method can be called at any point in time in your application, and it will either wait for a connection to be established or return the existing connection. It just makes writing this code much easier. So that should show the color of the Cre8te, whether it's enlightened or resistance, based on the room data. Now we're going to go through actually accounting for the score. So we've changed this so that now we, instead of waiting for the last player to be alive, we're waiting for all of the enlightened players to be dead or all of the resistance players to be dead. So we're going to find this death processing or game over component, and we're going to find where we have a players left for game over. This method here used to just count, is there only one player left? Now, instead, we're going to count the number of enlightened players. We're going to count the number of resistance players by going through the room data and seeing how many peers, how many of the alive players have the resistance faction, how many alive players have the enlightened faction in the room data. And then that's how we get our number of enlightened resistance. And then we call if, whoops, excuse me, I backed out here. If the number of enlightened players is 0, if the number of resistance players is 0, then we call handle game over, which now we pass in these new parameters. In handle game over, we'll also have to change the text so that instead of saying, congrats, you win, or congrats, you lose, it just says that it's a tie if we have the same amount of players for resistance and enlightenment, or if we have more enlightened players than resistance players, then the enlightened win, otherwise the resistance win. So this is pretty straightforward. It's just changing the numbers that we're counting, and it's just changing the text that we're showing. And the code again is here in this link. So I think that's it for the final build. This should actually give us a full working team scoring version of the game. Here we have a video of how it should look like. Obviously, you don't have 8 players, so you're probably not going to see this, but you can test with one and see if at least you get the right color. And then when you have more time, you can test with another person. We're going to wait a little bit too on this. There's no checkpoint here, but I'm assuming that we should do a checkpoint. So I'm going to go back here and kind of highlight this code, maybe see if we can get some checks, see if I can help with some issues.
Get some checks. I've also shared the link to the final project. You can clone it and check it out for yourself or play it. If you want to, I don't know, go in the Slack and ask anyone to join, and you guys can play with 8 players, perhaps. I don't see any checks, any green checks.
I'm going to also go back to the color because I know this last step was 2 big things or 2 things to test. So the color part, again, I'm going to go back here. Important that the async keyword here on spawn Cre8te and on get player color. So async spawn Cre8te, async await get player color, async get player color here. And also enlighten spelling is hard. So make sure that it matches everywhere or use a constant.
Yeah, maybe we can go into the networking challenges now, and
Sure.
then
Yeah, well, and that may be a bit. So yeah, maybe we'll focus on that, and then we can go back and troubleshoot for people and stuff. Since this is the last slide, we can just dedicate the last few minutes to troubleshoot any problems. So there's a few networking challenges that you'll encounter as you develop applications with shared AR. Examples of challenges in this hotpot application. The biggest one was synchronizing jumps, and you can see on the right how every crab in here is not really like, it's not like a perfect choreographed dance team, right? Like every crab, it's almost like every crab for himself. Like they kind of jump, but you can see that each screen is definitely not in sync. You can even see like this one jump and then it jumps like almost half a second later on the other screens. But the important part here is while the animations are not perfectly in sync, the game state, the things that count, like how many crabs are alive, how many crabs are dead. Notice the count of the crabs. You can see here the 4s, that's the game state. 3, they all 1, they all go down at the same time, right? So there's two kinds of synchronization. You want the animation synchronization, you want all the visuals, all that stuff does not have to be perfectly in sync. And it will never be, because there's latency between clients. So I will never receive, I will know that you have jumped maybe like 200 milliseconds after you actually have jumped. So it's impossible for me to know that immediately. So it's okay. Like as long as when I jump, that means that I jumped and the game doesn't kill me. That's all that counts. All that counts is that the state is consistent. Other peers know that I died when I've died, even if they see me jump later. All the peers know that I did not die, etc. That is the game state. That needs to be consistent. All other peers will not notice if they see me jump like 100 milliseconds later. And so in order to synchronize this jump, and I'm going to kind of jump into code here, what we did is there is a jump controller component that handles jumps locally and also handles jumps for other crabs. So this actually does a little bit of both. Now, what's key here is this component does not, you could think about this as, well, I'm going to receive a message from a player that they have jumped, and then I'm going to jump. If you do that, then it's really hard to, let's say you get this message 200 milliseconds after this player has jumped. It's really hard for me to kind of roll back or simulate that jump 200 milliseconds later if I just think about it as events in time that just happened once. Instead, if you write the code in a way where everything is lerping, so notice this is your classic lerp of this is my time divided by, this is my time at which things happen divided by the duration of my lerp or my jump. If I just think about it as I have a start time of this jump may have started 200 milliseconds ago, this jump may have started 500 milliseconds ago, but I created a component that will animate the crab, either mine or someone else's crab, to be jumping at a specific position at a specific time, no matter when it started. So I can receive this data. This data is networked, by the way. This jump start time here is using A-frame. This component is networked through A-frame. And this jump start time here is using A-frame network data. So whenever another player jumps, this jump start time's being set at any point in time. And so what you may see, if we go back to the slides, and that may be hard to see, by the way, with the slides here. But what's happening here is that maybe this peer here, this blue crab here, started jumping like 200 milliseconds ago. This jump will go faster and snap to the 200 milliseconds. It will actually like kind of show as if I'm 200 milliseconds up in the air instead of just like being delayed, if that makes sense. This is a bit complicated. So, go back through the replay, kind of like re-listen to these words, and maybe you can also read a little bit about interpolation and lerping and networking interpolation and so on. But this is, if you have to come up with anything of this talk about synchronization and latency compensation, accounting for latency, is that if you can use lerping for doing animations for, let's say, like player jumping, player movement, whatever, you should do that. You should use lerping and use a start time that is sent by another peer to do something. Now you may be asking, okay, how do I make sure that the start time is the same for all peers? Because everyone has a different clock. So this is where server epoch comes in. This is, I believe I put this in the slides, and apologies if I didn't, but where are the slides here? Oh, here in the tab. sorry, there you go. The Zoom thing. Okay, so this is the Zoom connection server epoch milliseconds here is going to be your savior in a lot of the situations where you either need to know when a peer died, where you need to know when someone jumped. You're going to want to use this server epoch milliseconds. So notice that when this code is for the local player. So when I receive a click event, when I'm tapping on my phone, I'm going to set this data jumpstart time milliseconds to the current server epoch. This is a synchronized time that goes through our Niantic servers. And you can think about it as like the classic NTP, I think it's called NTP, the time servers, where this is about maybe a dozen milliseconds off. This accounts for player latency. So you don't have to worry about that. You can just think of this think about this as a universal clock. So by doing this, what I'm doing is I'm telling all other peers, hey, this is when I started jumping, and automatically all other peers will be able to use this data.jumpstart as a universal jumpstart that matches my clock, that matches this clock that I have information about, the server epoch milliseconds. That is one network challenge, synchronizing the jumps. The other network challenge that I want to talk about, and I know we're a bit on time, but I think it's interesting, is death race conditions. So one thing that latency is the biggest kind of cause of these things. And one issue that we were having when players were dying, I'm going to go through the death processing here, is that players were receiving, let's say you died at time A, and you were receiving a message that another player died like 100 milliseconds before you, but it was already too late because you already decided that you died, therefore you lost the game. But maybe that other player died before you just didn't receive that information until later on due to network latency. A common technique to solve these kind of race conditions, because we don't have server authority and we can't say, we don't have a central place of information that says, no, this player has died, not you, undo this. Instead, we can have what we call a leeway or a window of opportunity, a window for clients to catch up. And I think this is called event queue. There's different ways developers call this: event queue, task queue, what have you, delayed task queue. What this does is you create a queue that every X amount of milliseconds, in this case, every 200 milliseconds, processes deaths. So rather than saying when I die, I immediately account myself for dead, when I die, either when I die or when someone dies. So this is actually, I have died. This code here handles me dying. When I die, I put my death in a queue. So I'm not immediately dead. Instead, I say, I'm going to wait at most 200 milliseconds for this. And also, I'm going to do the same for whenever, notice this, I'm going to talk about this in a second. Whenever I receive a peer message that says that they have died, I'm going to put this in the same queue. What this means is now I have time to say, okay, in the last 200 milliseconds, who has died? And so that's when I go through all of the deaths in this last 200 milliseconds and decide that if a person died 100 milliseconds before me, then they're dead and not me. This actually should be sorting by death time. I don't think it is, but the next step to this would be make sure that, because we're sending the death time again in server epoch, which is not here, somewhere else, then we know that at X milliseconds, this other peer died. So we know which peer died first. So we're using, again, the server epoch milliseconds. I believe this is used actually in here. So apologies for the code jump. But if you search for server epoch milliseconds, you'll probably find the death here. So this is when the client died event is generated. We also use the server epoch milliseconds to get the time of death that is synchronized across all clients. And when we receive that, we send, this is the peer message part that I was talking about. This sends a network message to all other peers that says, hey, I have died and I died at this time. And this is how we receive messages from other peers saying, hey, if this peer has died, add this to the death queue with the time at which that peer has died. And that is how you can solve this kind of race conditions. I know it's a lot. So again, go ahead and look at the sample. This is actually in the hot pot too, so you don't even need the final, but it's also in the final sample. Look at how this game queue works. As I said, know that this is actually not perfect because it doesn't look at the time of death as it should. So it just looks at the last 200 milliseconds, and this could be improved. But it does give you an idea of this technique for solving race conditions that accounts for latency. And by the way, you can increase this latency, this 200 milliseconds here. This is just based off of, this is your worst case latency. So this game would work best under 200 milliseconds because the deaths are accounted for in the last 200 milliseconds. If you wanted to solve this with an application level solution instead of having this queue, you could also say, hey, what if instead of counting, instead of counting the deaths when the ladle actually hits, what if you counted deaths when the ladle gets to the end of the pot, right? So you could say, this crabs don't count for deaths until you're done with the sweep. And that gives you like almost a second to wait for all the deaths to be processed, if you will. So that would be another way to do it. It may be smoother. A lot of networking game development is about tailoring your application to, it's like a smoking mirrors where you're solving race conditions as you display something in the game so that the player doesn't know that it's happening. Which is a lot of what we just talked here in networking challenges. And I know that was a lot. Hopefully that also gave time to catch up here. I don't know why I'm not presenting as I should, but that is all for the workshop work. And then we are going to kind of just go through the summary of what we've learned. So we've added a faction selection that we synchronize via room data store. We've implemented team scoring that is used by using peer messages. Whenever a peer dies, they send a peer message. Whenever they receive that death, they're registering for peer messages. And we've learned about the clock sync, which is used in so many places in our sample for resolving race conditions. So next, I believe we're going to go through, there's a resources slide that you have access to. I'm not sure if this is Chanel, if you link that to them, right?
Yep, it's in the Slack. Just wanted to make sure that they know it's there.
Okay, great. And then there are a few projects that are available for you, like the Hotpot Hub that you just cloned. Share Lobby is just a template for learning how to use the lobby that we talked about at the beginning and the Hotpot Hub uses. And this project, fully coded and all working, is available as the Cre8te Shared AR project. I believe it's called Cre8te Shared AR Workshop. And yeah, that's it for things you could look at. Oh, that's the resource guide, right? And maybe we have some Q&A. Yeah, time for Q&A. I think that should we stop recording? How does that work?
Yeah, no, we'll continue to record the questions, and let's go into Q&A. So we are going to skip the troubleshooting. If you feel like you still need some technical support, please go to the 8th Wall Developer Slack channel, and in the help and support channel, Evan and Ian will be able to help you guys in there. But yeah, there's some questions, and I'll read them out, and Ria or Danny, y'all can answer them. So I see Camille, you asked a question, what are the events we can use to add lobby and NAF listeners? Let Ria or Danny answer this.
Yeah. Okay, yeah, I was actually typing this, but I will just well, I'll do both, but I'm gonna answer now. So for NAF, as long as you use the window.naf accessor after the room has joined, so after you get the lobby8.room joined event, I think that's the earliest that you can listen to that. The other one would be if you listen to lobby8 dash countdown start, I believe that's the one. Yeah, I think that happens after room join. So lobby8 countdown start or lobby8 room join, they both can be used. Lobby8 room join, the advantage that it has is it gives you a room connection object, so you can just use that there if you need to do anything with networking. So that's probably the recommended one. I'm gonna type that there as an answer. Hopefully that answers the question. I'm not sure if you need any other access to any other NAF APIs.
Yeah, awesome. Thank you, Danny. And then there's a second question from Frank. Is TypeScript available? The console log myself is kind of annoying.
Yeah.
Fixing typing everywhere. So yeah.
Yeah. So TypeScript is available. I think we use JavaScript for a lot of our samples because it's most commonly known, but you can definitely use TypeScript. And I think in some of, so I did some of these through TypeScript. I'm trying to find here. But I think some of the code may be in TypeScript. If not, definitely you're able to use it.
Awesome. Thank you for the answer. That sounds really helpful. And I know that Ria, you were answering a lot of questions while Danny was presenting and typed them out. Is there any questions and answers you want to kind of just address to the audience?
Whoops.
I said it's okay. Sorry, we're in the same room. So I think Kushagra, you asked a question just about like there's issues changing the name and what appears on other people's screen. Would love some more feedback on what you observed. So it might be hard for you to reply to that. If you would like to unmute, feel free.
Yeah, you can unmute yourself or type it in the chat, Kushagra.
Hi,
Okay.
Ria.
Hi.
Yeah, so the issue was like when we were trying to change the name, it kept going back and forth. Like it came to the new name, then the old name. And when we played the game again, the second time, what happened was everyone could see only either their octopus or octopus or two, like other. But they weren't all the 4 octopuses because there were 4 players, and the game just ended. So it might be a network communication issue.
Yeah. Here, yeah, so actually there is you've activated our trap card. This is a known problem that we're going to fix very shortly because it's kind of not 100% repro, but we have an idea of where it comes from. So sorry about that. There are some issues with the trap spawning depending on the device. It really is a device only. So if you use browser, you'll never see this because I tried.
Yeah, I was actually trying it on browser also, the build that we did just now, and the
Oh,
browser one was pretty much smooth.
Wow, that's
So
yeah.
Fine.
Okay, you should just don't use my browser, and then it will not work, and then it will happen.
Like not gonna see this all this time. It's like once in a while we'll see it for specific clients. So yeah, we'll definitely be looking into that.
Yeah.
Perfect. Awesome.
Thanks for that. And I will mention that with the lobby, there is a known issue where when you type a name and someone else joins as you're changing your name will kind of be reset. That's annoying.
That's what is happening actually.
Yeah, that's annoying. Well, if you're interested in the implementation details, it's actually because we're changing, and since we talked about it now, you're very familiar with how room data works. So what's happening is you're typing the name and someone else comes in and the client is registered for room data changes. The client sees the room data changes and kind of resets the list and and wipes your name as you were typing it. So it's not great.
It basically refreshes the whole page again. Got it.
Thank you so much, Danny and Ria, and having Ian and Evan in the chat as well. And we'll see you guys next week. Thank you so much.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank you. Bye, Labardo.
Bye, adios.
Adios. Thank you, everyone. Thanks, Joe. Thanks, Myra. Thanks, Francis. Thanks, Kewal. Thanks, Tatu. Nice to see y'all.
Thank you.
Thanks, Frank. Thanks, Divkar. Diego, quiet today. Bye. Thanks, Felipe. Awesome. See you guys next time.